All right, so here we are for part 2 of the video. We're going to talk about the 4 characteristics of a correlation. And so we're going to start with form. Form simply just means the shape of the data points. So when we have a correlation, it's basically just a bunch of points that have been collected, and we see if they form a shape when plotted. If you see that the dots are forming what looks like a line, that's going to be a linear correlation. If they appear to be making this U sort of shape, we call that a quadratic. And then sometimes when things are just unrelated, there is no pattern, it is just random data, then there is no correlation at all. It means that there is no shape that can be determined to be being formed. Next, we're going to talk about the direction. You can see here that these are both linear. They appear to be making a line. The dots on top are going in an upward direction, so we would call this a positive correlation. And the dots here at the bottom would be considered a negative correlation. Kind of think of like slope, right? This would be a positive slope and this would be a negative slope. So that still comes into play when we're talking about the direction of a correlation. Next, we have the strength. So we know that some things can be very closely related and then some things are sort of related but not really. Kind of like the shark and the ice cream, they're kind of related but not really. So that wouldn't be a very strong relationship, but there is one. So you can see here that the relationships that are left are more weak. And as the dots get closer and closer together, almost forming a perfectly straight line, the correlation is getting stronger. So you'll recall that we said that the correlation coefficient is any number between -1 and 0. So if there's no correlation at all, it's going to be 0. It means that there's no shape, just random dots. It's going to be 0. And then as it gets straighter and straighter to more of a perfect line, then it's going to get closer to 1. Now notice that there's no negatives here because the negative is just going to change the direction. So the negative doesn't tell me how strong it is. It just tells me how the direction. So we're only looking at the number part and we kind of ignore the sign. An outlier is simply a data that does not fit in. Like all the dots seem to be going in the same direction, and then there's just this one random point that doesn't go with the data, and that point is going to be considered an outlier. It doesn't fit in with the rest of the crowd. Here, pause the video and I want you to take each one of these data sets and put them in order according to their correlation coefficients from the weakest to the strongest. Remember that when we do this, we ignore the negative signs because the negative just tells me direction. So you're only looking at the number part. So put them in order from weakest to strongest. Right, if you've done that correctly, then for number 1, you should get the following. We start with the smallest number, which is 0.07, and we should end with the largest, which is 0.98. Now again, the negative does not matter when we're talking about the strength. The negative is going to tell me the direction. So negative 0.98 is the strongest, even though it is negative. For example 2, you should get the following order. All right, so what we can also do is we can estimate what our R value would be just from a graph. So we first would look at this graph and we would say, okay, these dots appear to be going up, so we know that it's going to be a positive correlation. So I would not choose either of these. And it seems that they're going up, but they're sort of loosely together, not very tight. So this would be about a positive 0.5. Because there is a positive correlation, but the dots are not very close together, so about 0.5. All right, here, the dots appear to be going down, so this is going to be a negative correlation. And the dots seem to be a little bit closer together this time. So if we had to guess, we would say that the correlation coefficient here is closer to a -1. All right, try this one out on your own. Hopefully you said that this correlation is close to a +1. All right, one more. All right, this one you should hopefully chose 0. There is no apparent pattern. I cannot tell if the dots are going up or down, if they're increasing or decreasing. They're just all over the place, so this would be considered no correlation. All right, so that's what we can do from a graph is if we don't have any other information, we can sort of guess what our correlation coefficient is. And we'll talk about in a later video how to find the exact correlation coefficient.